Okay, let's get right into it. Have you ever stared at a big spreadsheet just packed with numbers and thought, what am I even looking at? Well, today we're going to put on our detective hats because we are cracking the case of how a mess of raw data can be transformed into a really clear, convincing story.
And here's our big mystery for today. It's something you've probably heard before, this idea that older adults actually have a bigger vocabulary than college students. I mean, is that really true, or is it just one of those things people say? This is the question we're going to investigate together.
You know, every investigation starts with a pile of clues. And this is ours. These are the vocabulary test scores as percentages from a group of 26 college students. Right now, it's just a sea of numbers. It's pretty much impossible to see any kind of pattern or story here, right? This is the raw stuff we have to work with. And this quote right here, this is our golden rule for today. The brilliant statistician Robert Abelson said it best. It's just not enough to have the facts. You have to weave them into a story that makes sense. So that's our job, to take these numbers and build a story that makes a really convincing argument, one way or the other.
So, how in the world do we do that?
Well, luckily, every data detective has a standard toolkit, and it's a pretty simple three-stage process. First, we're just going to get to know the data. Then, we'll summarize it, and finally, we confirm what it's telling us. So, let's start the investigation.
All right, welcome to stage one. This is kind of the exploratory phase. We're not really looking for final answers yet. We're just trying to get a feel for the evidence. You could almost say we're making friends with the data.
So in this first stage, we're a lot like a detective at a crime scene. We're looking for anything that seems out of place. You know, errors in the data or what analysts call outliers. Think of those as suspicious clues, numbers that just don't seem to fit. And most importantly, we're going to create a picture to see the overall shape of our evidence. And here is our first picture. This is called a stem and leaf display, and it's actually a fantastic way to see two groups at once. So how does this thing even work? Well, the numbers in the middle are the stems, that's the tens digit of a score, and the numbers on the sides are the leaves, the ones digit. So for example, if you look on the right for the college students, see that line 6-2? That represents one student who scored a 62%. Simple as that.
Now, two things should immediately jump out at you here. First, just look at the overall shape. The scores for the older adults on the left are clearly bunched up higher. And second, look at that 32 on the older adult side. See how it's way down there, all by itself? That's our outlier. It's a suspicious clue for sure, but we don't have any reason to think it's a mistake, so for now, it stays in.
Okay, so we've gotten to know our clues. Now it's time to move to stage two. This is where we start boiling the evidence down into cold, hard facts. This is where we really start to build the core of our case.
And whoa, right here, the difference becomes crystal clear. We've calculated the mean. That's just the average score for each group. College students averaged about 46%, while the older adults, they averaged over 64%. That is a huge difference. We can also see the standard deviation, which just tells us how spread out the scores were. And they're pretty similar, which means both groups had about the same amount of variety within them.
So, we can see a difference in the averages, but how big of a deal is that difference really? Is it meaningful? To answer that, we need to calculate something called the effect size. You can think of it as a way to measure the magnitude of our finding. Is this a small, interesting clue, or is it a giant, smoking gun? The effect size for our study, using a common measure called Cohen's d, comes out to 1.65. Now that's just a number for now, but it summarizes the entire strength of the difference between our two groups.
So, is 1.65 big or small? Well, according to the standard guidelines, an effect size of 0.80 is already considered large. Ours is more than double that. So the really crucial point here is, this is not a small difference. It is a huge, substantial effect. Our case is getting really, really strong.
Okay, we've followed the clues, we've summarized the evidence, and it is all pointing in one direction. But a good detective always confirms their findings. So now, it's time for stage 3, delivering the final verdict.
To lock this thing down, we use a tool called a confidence interval. Now this might sound complicated, but I promise you're already familiar with the idea. It's basically the margin of error you always hear about in things like political polls. It just gives us a range where the true average for the entire population likely sits.
And here it is, the visual climax of our entire investigation.
This bar chart shows the average scores for both of our groups. And those little lines on top of the bars, those represent our 95% confidence interval. That's our margin of error.
And this right here, this is the moment of truth. Look really closely. The top of the college student's error bar doesn't even come close to the bottom of the older adult's error bar. They don't overlap at all. This is the knockout punch. It's incredibly strong evidence that the difference we're seeing is real and it's not just some random fluke. So, case closed. Based on our three-stage investigation, getting to know the data, summarizing it, and then confirming it, the evidence is just overwhelming. The story the data tells is clear. In this particular study, the older adults really did have a significantly larger vocabulary.
Now, this three-stage toolkit is super powerful, and you can honestly apply it to almost any data mystery you come across. But there's one final, critical piece of wisdom that every good data detective has to remember.
And here it is. You've probably heard this before. Correlation does not imply causation. We found a really strong relationship, a correlation between age and vocabulary size. But that doesn't prove that getting older causes your vocabulary to grow. There can be all sorts of other factors. It's the most important rule in data. Just because two things are connected doesn't mean one is causing the other.
So, what are the big takeaways from our case today? Well, first, that good data analysis isn't magic. It's a simple, three-stage investigation. Second, that creating pictures of your data is one of the best ways to see the story that's hiding in there. And finally, and maybe most importantly, that this whole thing isn't just about crunching numbers. It's about building a powerful, evidence-based narrative.
We've just handed you the Data Detective's Toolkit. You now have the framework to take pretty much any set of numbers and start asking questions, looking for patterns, and building your own stories. So the only real question left is, what mysteries are you going to solve?